Hi everyone, Salam alaikum. I am Matur. The time has come to start with the secondary 2 physics. So please subscribe to our YouTube channel. So today we are going to start with the Unit 1. Unit 1, Behaviors of Light at Curved Surfaces. Behaviors of light at curved surfaces. So in this unit, we are going to cover two topics. Topic 1 is going to focus on reflection of light at curved surfaces, while topic 2 is going to focus on reflection of light in thin lenses. So in the first topic there, we are going to understand how light is reflected off on the curved mirrors or spherical mirrors like concave and convex mirrors. While in topic 2, we are going to explore how light bends as it passes through thin lenses, affecting the focus and image formation. So these are going to be our focus in Unit 1. So you need to follow well so that you don't miss anything out. So learning outcome. So you also need to understand the behaviors of light at curved surfaces. Behaviors of light at curved surfaces. How the light behaves when it hits the reflecting surface. So this is what you should know after the topic 1. So in short, for skills here, for skill you need to determine how to get focal point of a curved mirror. So after topic 1, you need to know how to get the focal point of a curved mirrors. Then the other skill that you need to have here is observational skills. How to observe when you are carrying out the experiment. So and have a careful prediction of the outcomes of the experiment. So the other one is knowing how to measure and collect data. Need to know how to measure and collect data in reflection of light on curved surfaces. Then altitudes, you need to show curiosity here. And lastly, you need to know how image is formed by curved surfaces and thin lenses, and why images may be formed in different ways. So, and why also curved mirrors are important. So, lastly, you will also know how thin lenses are important in optical instruments. So as we are going to start with topic 1, reflection of light at curved surfaces. Reflection of light at curved surfaces. So at the end of this unit, throughout this uh, topic, you are going to learn the reflection of light at shiny surfaces, and you have to get to understand what shiny curved surfaces are. The other things that you will also learn is application of laws of reflection at curved surfaces. Application of laws of reflection at curved surfaces. Then reflection terms used in curved mirrors such as uh, principal axis, principal focus, center of curvature, and related terms, other terms that are used in curved mirrors. And other things that you will also learn is spherical mirrors such as concave and convex mirrors. You will also learn about those ones. And another uh, spherical mirror is parabolic mirror. So you will also learn about parabolic mirror. So you will also learn how image is formed by spherical mirrors, how image is formed by curved mirrors, and also the formula of magnification, and the relationship of focal point, image distance, and object distance. You will also learn about how the curved mirrors or spherical mirrors are applied in our day-to-day life. So lastly, you are going to learn how you construct ray diagrams to locate the image of an object. So these are the things you are going to learn throughout this topic. So in secondary one, you learn about plane mirrors. So, and mirrors are not always flat, as you already learned it in that way. So some mirrors are curved, concave, of different form. So you should always know mirrors are not always flat, as you know. So in this topic, we'll learn about the reflection. So what is reflection? We already learned in secondary one that reflection is a bouncing off of light rays. So reflection is bouncing off of a light rays. So assuming this is the surface, then there is incident ray here on the reflecting surface. So these rays will be reflected in this direction. So this process is known as reflection. This is known as reflection. Bouncing off of light rays is known as reflection. So, and these curved mirrors are also applied in optical instruments such as uh, telescopes and side mirrors of a car and others. So they are applied in those areas. Reflection of light as shiny surface. So before we start with this, so let's really understand what reflection is, as you already learned it in secondary one. So reflection is divided into two. We have what is called regular reflection, and irregular reflection. So since we know reflection is a bouncing off of a light ray, like this is incident ray, so it will be reflected in this direction. So this type of reflection is known as regular reflection. Regular reflection is a type of reflection in which the parallel beam of light is reflected parallel. So like here we have the beam of light rays that is incident on the reflecting surface. So this beam of light will be reflected parallel. So this is known as regular reflection. So the other form of reflection is reflection that happen on rough surfaces. If we have this surface as reflecting surface, this surface which is not smooth, when a parallel rays of light collide with the surface, they will be reflected at different angles. They will not be reflected parallel the same way they were incident on the surface. There will be irregular reflection. So this type of reflection is called irregular reflection. Irregular reflection. Since you have known the two, type of reflections, this is known as regular reflection and this is irregular reflection. So on curved mirrors, this activity is to demonstrate reflection of light at shiny curved surfaces. Shiny curved surfaces are surfaces which are silvered on one side, either the inner part or outer part of the surface. So in this experiment here, you are being given the materials, new spoon, then cup, mirrors, and pieces of dry cloth. So to really understand about cup mirrors, you can take an example of a spoon and see how a spoon to see the shape of the spoon. So if you look at the shape of a spoon, this part of a spoon is curved inwards. It is curved inwards. So the image that will be formed by this part will be different from the image that will be formed by the outer surface of the spoon. So, and if we talk about curved surfaces or curved mirrors, you get to understand the surfaces of two sides of a spoon, the one outside and the inner surface. So they are not the same. For a curve reflecting surfaces, they are broadly classified as concave, convex, and parabolic, depending on their shapes. If we take this curved surface, this curved surface, then we silver one side, the inner side of the inner part, the one that curve inwards. If we silver this part to be shiny, it will make this inner part shiny. So this kind of mirror reflecting surface, we call it concave mirror. So a concave mirror is a type of mirror where the inner part the inner part is silvered. It is made shiny. So like the spoon here, if a mirror is silvered inside, the one that is curving inwards, like this part of the spoon, we refer to it as concave mirror. So the same again, if we take uh, this curved surface, then we silvered the outer part. We silvered the one that curved outside here, this outer side here. If we silver it for this side to be shiny, and this part is not silvered. So this kind of mirror formed by silvering the outer part of the curve here, it is referred to as convex mirror. It is known as convex mirror. It is a mirror formed by silvering the outer part of the sphere. Parabolic mirrors, they are special. They are of this form. So parabolic mirror is like cutting the section of the part of the cone. It is only silvered inside, but outside is not silvered for parabolic mirrors. The inner part is silvered. They are like concave mirrors, but due to the form of the shape of the parabolic mirror, they become different from concave mirrors. That is how three curved mirrors are formed. So, for how do they differ? How do concave mirrors, convex mirrors, and parabolic mirrors differ? They are different in terms of shapes and in terms of properties, in terms of characteristics that we use to identify them. For concave mirrors here, what happens? They converge light rays to a single point. So if there are some light rays coming from a different source, like this is a light ray, so it will be reflected. This light ray will be reflected in one focus. All the light rays on curved mirrors are reflected at one focus. So let's try to draw how they are reflected on one focus. On one focus. Light rays are reflected at the same focus. So this point is what we call focus or focal point. So the light rays here will pass through the same focal point. They are brought to one focus. They are brought to one focus compared to other mirrors. So these are reflected rays. So you see, all the reflected rays are brought under the same focus. So that is one of the identity or characteristic of concave mirrors. The reflected rays appear to be in one focus. For this kind of mirrors, the light rays diverge after reflection. So when a light ray incident on surface, they will be reflected outward. So they will not have a common focus like the one of concave mirrors we observed before. So for this one here, the rays of light will diverge outwards, and they will not have a common point. like concave mirrors. Concave mirrors before had one focal point. The reflected rate had common point. But for convex mirrors, the reflected rays do not have common point. That is called focus. They don't have it. So after reflection, they move to different directions. They move to different directions. Parabolic mirrors, so they bring uh, rays of light, the parallel rays of light to one focus, to one focus. This is known as parabolic mirror. Parabolic mirror. Oh, so this is it. And in this unit, we will study curved mirrors. Such mirrors are also called spherical mirrors. So other name of curved mirrors, they are known as spherical mirrors because they can be formed from the section of a sphere. They are formed from section of a sphere. From the section of a sphere. So that's why they are called spherical mirrors. Spherical mirrors here can be thought of as a portion of a sphere. So they can be cut out of the sphere. That's why they are called like that. So after cutting the portion of a sphere, so then one side is silvered. So one side of the surface is silvered to form reflecting surface. To form reflecting surface. There are three types of spherical mirrors: concave, convex, and parabolic mirrors. So curved mirrors are silvered on the inside of a sphere, while convex mirrors are silvered on the outside of a sphere, like the part of the spoon. So this inner part, when it is silvered, it gives us concave mirrors. While for convex mirrors, they are formed by silvering the outer part of the sphere. Concave mirrors are formed by silvering this part, the outer part. This is the part that is silvered, the outer part of the sphere. So that is how they are formed. So for parabolic mirrors, so they are being cut from the section of cone, and the part that is silvered is the inner part, like this side. So they are just have the same properties with the concave mirrors, but for parabolic mirrors, what makes them different is the shape. Look at this shape here and this shape here. So that is what makes them different, because of the shape. So but they are all formed by silvering the inner part or the inside of the sphere. So that is how they are formed. All of them are referred to as curved mirrors. All of them are referred to as curved mirrors. Okay, how are the beams of light reflected? For concave mirrors, when the light rays hit the surface, the shiny surface, so they are reflected and pass through one focus. They pass through one focus. This is the focal point they will pass through. So in this focal point, all the reflected rays will pass. Yeah. The reflected ray. This ray which is reflected like this. So it will pass through that focus. So this ray of light will pass through the focus here. It will pass through the focus, reflected ray. So, and this one will also pass here. Then this thing also will also pass here. So for concave mirrors, the reflected rays all pass through the same focus. They pass through the same focus. That is how beams of light is reflected on on concave mirrors. This ray that is passing through the principal axis will be reflected along the same line. So what about the other rays of light here? These rays of light that are parallel with one another. So they will be moving in different directions. They will diverge away from the mirror. They will diverge away from the mirror. For parabolic mirrors, they are just the same like concave mirrors, but due to the shape, so they are not the same. So the outer part is not shiny, but the inner part is shiny. So the parallel rays here for parabolic mirrors, the parallel rays here, so are reflected in the same way like for concave mirrors. They all pass through the same focus. Let's say this is the focus and this is the pole. So this ray here will be reflected along the principal axis. So what about the other rays? The other rays of light here will pass through this focal point. This focal point. They will all pass through focal point. So that is for parabolic mirrors. That is how light rays are reflected. So these curved reflectors are usually made from highly polished metals and glasses. So the curved mirrors are usually made from highly polished metals and glasses. So they are formed from these metals or glasses. So that is how they are made. Now let us come to applications of laws of reflection at curved mirrors. Application of the law of reflection at curved mirrors. What are the laws of reflection? So you have to know the laws of reflection. So we say for the laws of reflection, the first law of reflection is that the incident ray, the reflected ray, and the normal all lies on the same plane. That is law of reflection of light on plane surface. We also say that the angle of incident is always the same as angle of reflection. Okay, for those laws we have to know how they are applied on curved mirrors here. So this activity is to demonstrate application of laws of reflection at curved mirrors. So here you are given curved mirrors, concave and convex, then source of light, ray box. So in step 1 here you are being told to use to use 5 white rays from the box to strike the concave mirror in a straight line. So this is the ray box. This is the ray box. Let's say this one is a ray box, and then this one is our curved mirror. This is our curved mirror. Curved mirror. So it is meaning that this part here outside here is not silver. It is not silver. This part here, the shaded part here is not silver. So this is concave what? Concave mirror. Concave mirror. So for concave mirror, and this one is ray work. You are being told to release 5 rays of light. That is 1, 2, 3, 4, 5. And also you need to know the center of curvature. Let's say this is our center of curvature. Center of curvature of the mirror. So let's make this one to be a focal point or focal point. Okay, after knowing all this, you need now to draw the rays of light, the rays of the light. So this ray that is passing through focus is going to be reflected along this line, along the same line. What about the others? Let's say this one is ray 1, 2, 3, 4, 5. So let us start with the ray 2. How is it going to be reflected? This ray is going to be reflected in this way. See? It will pass through focus. And the same for 1. Ray 1 will move in this direction. So you have to draw the reflected ray in their appropriate direction. This one also will pass through the focus, ray 4, and ray 5 is going to pass through the focus. So this is how it is going to look like. So now in that experiment, you have also been told to measure the distance between the incident ray and reflected ray. So these rays here that are coming out from the rainbow, we call them incident rays. While these rays here passing through the focus, we call them reflected rays. So now you need to measure the distance between the reflected ray and incident ray. So for example, this and this one here. So for this incident ray, here, it is moving parallel to principal axis. That line is called principal axis. So the reflected ray is passing through the focus. So what is the distance or the angle between the what? What is the angle between the two rays, the incident rays and reflected ray? What is the angle between them? So this point is known as normal. It is called normal. So for us to measure the angle, so we are going to measure the angle of the incident ray to the normal first. The angle of this to the normal. So assuming the angle here is what is x. So what will be the angle between the reflected ray here? Between the reflected ray and the normal. What will be this angle? What will be the angle there? So the angle is going to be x2. So it is going to be also x. So because in the law of reflection of light, we say that the angle of incident rays is equal to angle of reflected ray. We have also seen that incident ray, which is this, and this normal point here, and reflected ray here. All these three, they lie on the same surface. The three lies on the same surface here, on the same surface of the mirror, on the same point of the mirror. So this will let us understand the two laws of what? Of reflection. So here are the laws of reflections. So the first law of reflection is that the incident ray, the reflected ray, and the normal at the point of incidence all lies in the same plane. So the incident ray and reflected ray and the normal at the point of incidence all lies on the same plane. They all lie on the same plane. So the other law of reflection of light is that the angle of incidence is equal to the angle of reflection. They are known as laws of reflection. Laws of reflection. So to apply the above laws on reflection of light at curved surfaces for each incident ray, normal line at the point of incidence on curved surface must be drawn, and then the laws of reflection are applied, like what we did there, to draw how the rays of light here are reflected and the angle between them. See, this brings us to conclusion by saying that for any incident ray traveling parallel to principal axis, what we call principal axis is this line here. That line is what we call principal axis, the one that passes through focal point there, the one that passes through focal point. So for all rays traveling parallel, what are those rays traveling parallel? These rays all are the one traveling parallel to principal axis. So for this kind of rays, all of them, they pass through focal point upon reflection. So after reflection of these rays here, so what will happen? What will happen after reflection of these rays? The rays will be reflected and pass through the same what? The same focus. So they will be reflected and pass through the same focus. That is for concave mirrors. So for convex mirrors, upon reflection, the focal point of concave mirrors is just behind the mirror. It is behind the mirror. This point is known as focal point for concave mirrors. So that is the first law. So the first law of reflection of light on curved mirrors is here. Any incident ray traveling parallel to principal axis on the way to mirror will pass through a focal point upon reflection. So that is the first law. The second law is here. Second law of reflection of light on curved surface. Any incident ray passing through the focal point, on the way to mirror will travel parallel to principal axis upon reflection. So it is saying any incident ray, this is incident ray that is passing through a focal point on the way to mirror will pass, so will travel parallel to principal axis. So this line is known as principal axis. So will travel the same way, the same path as it is being reflected here. So it will pass through a focal point. So that is what second law is saying. Any light ray, any ray, any ray that is passing along this point will be reflected the same path. So it will move along the same line. So therefore, the second law says that any incident ray passing through the focal point on the way to mirror will travel to principal axis upon reflection. Upon reflection. So this is it. So don't forget law of reflection of uh, light at curved mirrors. Those are the two laws. These are the two laws. Don't forget of them. In exam, you can be asked to mention two laws of reflection at curved mirrors. So thank you so much for watching this video. Please like, share for other audience to meet our video, and that is going to be a great motivation for us to continue doing this. And I really appreciate you. If you have any question, put it down there, comment, don't hesitate, we'll answer you immediately. If there is any word of encouragement, so don't hesitate to let us know also, so you can be helping us in a spiritual way. God bless you, and God bless South Sudan. We are going to continue. Nothing will stop us. Bye.